was asked in 2025 ICSE board paper. I found this very interesting because this is not the kind of question which was asked before. A graph-based question asked in load effort kind of topic. So graph shows load against effort for a lever with load and effort on the same side of the fulcrum. So this is the first important thing that we need to underline: load and effort on the same side of the fulcrum. So load and effort on the same side of fulcrum. So either it can be you know case 3 or case 2, because in both in case 2 and case 3 of these lever diagrams, the load and effort are on the same side of the fulcrum. Uh, I hope you understand these class 1, class 2, class 3 lever kinds. So here in class 1, the load and effort are on the opposite side, and in class 2 and class 3, you know that they are on the same side of the fulcrum. So this case, the graph which is given, this might be a case 2 or case 3. So we need more information to understand what kind of case this might be. So the first question is, which attribute of the load versus effort graph must be calculated to determine its mechanical advantage? Okay. Now, we require some mathematical background to do this kind of question. The first thing that we need to understand is that I'll write it here. So first thing that you need to understand is that equation of a line which passes through origin. The equation is given by y is equal to mx. So this is the first thing that you need to understand. Giving bit of mathematical background, you might know it. Even if you don't know it, you can just review the concepts. So y is equal to mx is the equation of a line which passes through the origin. Now this m is called the slope of the line. Slope of line. And how do we find slope? The formula of slope is delta y by delta x. Delta y, y2 minus y1 upon x2 minus. So this is what is called the slope of a line. Within minutes you will understand why do I require the slope of the line. So y is equal to mx is the slope of a line. So the slope of a line is given by delta y by delta x, where y2 minus y1 upon x2 minus x1. So how do I calculate the delta y in this case? I can find the difference of 50 minus 0, which will be equal to 50, divided by 25 minus 0, which will be 25. So 50 upon 25 is equal to 2. So m, which is the slope of the line, so the slope of this line is equal to 2. What does 2 represent? Let's try to understand. See, I know that the mechanical advantage is given by load by effort. This is the definition of mechanical advantage. So load would be written as mechanical advantage multiplied by effort. These two would be multiplied. So load can be written as, in this case, if we compare this load is equal to mechanical advantage into effort with this line, we understand that y-axis would be represented by load. This is my y-axis. X-axis would be represented by the effort. This is my x-axis. And now we understand that this m is equal to 2, which is the slope of the line, is actually the mechanical advantage. So remember that if you are given a load effort graph, the slope of a load effort graph gives the mechanical advantage of the lever, which is being talked about. In this case, it will be case 2 or case 3 that we'll find, that we'll discuss. So mechanical advantage for this case is 2. I hope you are with me till here. So now once we know that the mechanical advantage is 2 in this case, we know that between class 2 and class 3, mechanical advantage is more than 1 for class 2. For class 2, not for class 3. So this is a case of class 2 lever. I hope you are with me till here. So this is not a class 3 lever, this is a class 2 lever. So which class does this lever belong to? This is a class 2 lever How did you arrive at this conclusion? We arrived at this conclusion first because it was mentioned that the load and effort are on the same side of the fulcrum. This was the first. And we understood, we calculated that the graph is, that the slope of the graph is 2. Mechanical advantage is greater than 1. That is why this is a class 2 lever. How did you arrive at this conclusion? So this was a question which was asked in 2025 board paper. Then same kind of question was asked in the compartment paper in the same year, 2025. This was a question which was asked in the compartment paper. For a lever, a graph is plotted with a load on y-axis and an effort on x-axis. This is load, this is effort. Which of the following represents the slope of the graph? As we have discussed, L upon E. Mechanical advantage is equal to L upon E. So my answer would be A part. So I hope this is useful. If you want to do more questions like these, I have made this full lecture where I have discussed all the questions from last few years. I have also covered the specimen papers also, and all the topics from lever as well as Pulley questions I've done. I'm putting the link here as well as in the comment section. So I hope this was useful.